So very similar to what we were doing yesterday. These are definite integrals instead of indefinite integrals, so the idea is going to be the same. We just have to remember what to do with the boundaries. Thoughts on where to start this one? Okay, this is one where we can substitute u for the denominator because in the numerator we see the derivative. Okay, so
And why can't it talk
because it won't be easy to integrate. We need something that will be easy to integrate, and that would just become yuck. So u equals x plus cosine x. If u is x plus cosine x, okay, du is 1 minus sine x dx. Are you seeing those pieces where this is going to match up? Okay, so we don't really need to do anything with that, do we? Now, if you recall, we have options of how to work this. And I have a way that I'm going to kind of consistently try to do. But these bounds right here, because this problem is in x's, these are x values. Okay? So those numbers can only be plugged in place of x's. So if we work this through in u's, if we're going to use those boundaries, we have to come back and use x's. Okay, we have to plug back in this right here. Okay, the other option is we can change these x's to u's, whoops, and then we never have to go back to x's again. Okay, so if we're doing that, what do we have here? And remember, how are we doing this? If x equals 0, you're plugging it in to your u definition. So that means u is 0 plus cosine of 0. Cosine of 0 is, did we say it? 1. Okay. And then if x is pi over 2, then u is pi over 2 plus, what's cosine of pi over 2?
0.
Okay. So pi over 2 plus 0, which I don't need to write the plus 0, right? Okay. So now we're ready to rewrite. Okay. X plus cosine x is my u. So u in the denominator. 1 minus sine x dx. 1 minus sine x dx is my du. So this just, everything matches up. It's 1 over u du.
You could write du on top.
You could, yep. And then my boundaries were 0 to pi over 2. Now they're going to be 1 to pi over 2. Integrate. Okay. Integral of 1 over u is natural log of absolute value of u, evaluated from?
Why is the absolute value? Oh, because I hate that.
Okay, so 2 different questions. First of all, okay, the plus c, I don't use when I have the boundaries. The absolute value is because we can't take natural log of a negative number. It's undefined. Okay, it's D and E, if you will. Okay, and so we put those around there to ensure that u has to be positive. So at this point, we're ready to substitute and evaluate, right? If you did not change these boundaries and we were still working with 0 and pi over 2, we'd have to go back in and put x and x plus cosine x right here. But since we changed it, we just get to plug it in. Natural log of pi over 2 minus natural log of 1. Okay, so definite integrals, it's always plug in the upper minus plug in the lower. Rule of, yeah, just, as he said, just, it's the rule, that's why. Are we okay? Okay.
minus x.
Yeah.
We have no other choice.
Yeah. Yeah, that's, I guess I should, after my disaster yesterday, I should double check that that's the direction I should go, but that's what my brain was saying too, so. Okay. On this one, you're gonna use u as 2 minus x. If u is 2 minus x, what is du?
Negative x.
It is negative
dx.
negative dx, because the derivative of 2 minus x is negative 1. Okay? And then I don't see, when I go to start plugging stuff back in here, I don't have an extra negative laying around, do I? So we're not going to find a negative dx, so we need to divide the negative over to the other side. So negative du is equal to negative dx.
Regular dx.
What did I not? I don't know what I said at this point then. Is what I have written correct?
Yes.
Are we okay with what that is?
Yes.
So wipe off whatever I said because I don't know what I said, but obviously, based on a couple of looks, I said something weird. Okay. Also, remember, these are
X.
x's, right? So, if x equals 1, what is u? 2 minus 1, which is 1. If x is 3, what is u?
Negative
2 minus 3, which is negative 1.
Thanks.
Okay. Set this up. So 2 minus x is going to become u. So we have e to the u. Dx is going to become negative du. Negative is like a constant, so I like to put it out front. It was x equals 1 to 3. Now it's going to be
Negative 1 to 1 with a negative.
But then you gotta switch it over.
So then it's
So then you're
positive.
taking away that negative.
okay. First of all, do you understand why I wrote it the way I wrote it here?
Yes.
Because when x was 1, the lower bound, now u is 1. That is your lower bound currently. Even though we can't physically do that, that is my lower bound. X equals 3 was my upper bound, so u equals negative 1 is my upper bound. I know we can't do that, but that's still mathematically how we have to do this. You guys already realized the rule is you get to flip the integral, so now instead of 1 to negative 1, it's negative 1 to 1.
To make it negative.
E to the u du. Technically, it would be more of like a what? Negative of a negative.
Yeah.
But can we just say positive?
Yeah.
Because most of you were pointing that out to me before I ever got to do this. So, yes.
What AP do we have to do? We have to show that intermediate step.
This one? Is that what you're calling intermediate? Not necessarily, I guess. I mean, I don't know. I mean, if the steps follow and, you know, you should be okay. Okay, so what are we doing? Integral of e to the u is e to the u, evaluated from
Negative 1
negative 1
to 1.
to 1. So,
E minus 1.
I wrote minus e to the first, minus e to the negative first. You know I'm not leaving that though, but
You're the first minus whatever
e minus 1 over e is what I wrote.
Am I just adding wrong, or how do you get negative?
This negative 1? Is that what you're talking about?
Yeah.
Because 2 minus 3?
It's algebra, so.
Oh,
I'm not sure what you were doing.
Are we putting it back in the x's, or are we putting it in the u's?
X equals 3. X equals 3. So 3 goes in place of x. X equals 1. So
This is why graduate was bad for you. Oh my god.
Is the problem fixed?
Yeah.
Okay. And I guess that's where I could have been writing out that, u equals, what, that one was 2 minus 1, this one was 2 minus 3. I actually have that kind of written out in my notes, I just didn't write it out up here, but
I know.
that would have been helpful,
See, I was
probably.
doing
Write that
u.
down for later.
I was doing u minus -1, and so then I kept getting 1, and I was like, what? Or 4? No, 3. I kept getting 3. And
You just
so
kept getting wrong answers. Okay.
I was freaking out.
And she's like, no one else is arguing with her.
Oh no.
No one else is also disagreeing with Mrs. Sargent, so what is the problem?
She's.
Okay.
Okay.
Okay. Are we good now, though?
Yeah.
Okay.
Whoa. Let's just skip that one. Straight to D. Mark it out. 3 over x. Can we just be used?
It is 3 over x.
Is it really?
Yeah, well, it can't be x squared.
Why can't it be x squared?
Because it's just 2x.
3 over x squared.
Okay.
We got it.
Sorry, I had a brief moment of, I don't know what to do here. So I was trying to figure it out before I looked at my notes, although I checked myself this time.
Yesterday.
I just had a massive confusion moment, and I don't know. Maybe it seemed massive to me. Okay. Any thoughts?
3 over x.
3 over x?
I got a question for you.
Okay. Now, we're saying 3 over x, but when we go to take the derivative of it, what form do I want 3 over x to be in?
3x.
This is 3x to negative first, just because that's how we take the derivative, right?
Yep.
Okay. du.
Negative 3 over x squared.
Okay.
Yes.
So multiply by -1. -1 times 3 is -3. Subtract 1. -1 minus 1 is -2. So I currently have it as -3 over x to the negative second, or -3 times x to the negative second. But you need to realize, what do we know about x to the negative second? This is -3 over x squared. And that's where, if you didn't see it coming, your aha moment of, oh, this is actually going to work.
Yes.
Okay?
Then take the negative up. Right? Negative up to you.
What'd you say?
Make 50 negative. You're gonna make
Well, not just negative, but also the 3 has to go.
Negative 1/3.
Because I don't have,
yeah,
this 3 is part of the exponent that's part of the
I
u.
realized that.
I don't have a 3.
Yes, it's -3.
Except it's not going to be -3 to you.
Negative 1/3.
Since this 3 is currently on top, it's like multiplying by 3.
Yep.
There's no 3 in my problem, so we need to divide the 3. So we're going to say -1/3 du is going to be equal to what I just wrote as 1 over x squared dx. So I divided that -3 over to the other side.
Divide over the negative 3.
Well, you
Because I don't have, as I start matching things up, okay, e to the 3 over x, that's going to be e to the u. So, like, that's taken care of. And then x squared, okay, that's in the denominator. I don't have a negative. I also don't have a 3. Okay, like, I don't have that in this problem. So I have to put it on the other side. Okay. We're also going to need to do our u substitutions, or our, so these are x's. So if x is 1, what about u?
3.
It's going to be 3 divided by 1, which is 3. If x is 3, then u is 3 divided by 3, which is 1. Okay? Are we ready?
Okay, so I did have to switch.
Yes.
Yeah, you did have to spare once.
Switch what? The integral.
So,
Okay, I'm moving along. So, e to the 3 over x is e to the u, right? There's my u. X squared in the denominator dx, x squared in the denominator dx matches up with negative 1/3 du. My boundaries that were 1 and 3 are now 3 and 1.
so you make it.
Okay, so can't have the bigger bounds on bottom. So we reverse it, and so now this is going to read positive 1/3, 1 to 3, e to u, du. So 1/3, the integral of e to the u is e to the u evaluated from 1 to 3. With a constant like 1/3, I leave it out front. Okay, it's just easier because it's a constant. We can leave it out front and then plug in. So then it's e to the 3rd. That's plugging in the 3, and then minus, and now we're plugging in the 1, so e to the 1st.
And it's always upper minus lower, right?
Uh-huh.
Oh, okay, yeah, I did do it different.
Now, I'm looking to see what options I have.
You have to square.
E cubed minus e to the
Could you put 1/3 on the bottom?
Well, that's what I was looking to see. So, okay, options. You could leave it as 1/3 e to the 3rd minus e. You could e to the 3rd minus e over 3.
Oh, yes.
That's good too. You also, what I'm seeing,
3 over 3 minus.
and this is something that I want you to realize, there's a GCF here. What do e cubed and e both have in common?
E.
So another option is you could factor out the e, which when you factor out the e, it's going to go e over 3, because the 1/3's over there. And then here it's e squared minus 1.
See, there's where you can get squared up.
And then you also could say e times e squared minus 1
What?
all over 3. Now,
You just pick one.
yes.
We have to write them all down.
Okay, now, in all honesty though, why do I show all these?
Because AP is stupid.
Multiple choice.
There's 5 answers.
Okay. I mean, I just wrote, well, this, I'd say 4 answers. This one doesn't really count because I just took the 1 off here. But even though you get something as basic as 1/3 times e to the 3rd minus e, are you going to recognize that that's the same thing as this down here?
No.
Might not.
At some point.
I mean, hopefully, but that's, so, factoring out GCF, that is a key thing, okay? So if I introduce it to you now, at least you have a chance. That's my, right? Okay, so pick an answer, any answer.
I actually had something different than what was up there, so.
Okay.
But it was right.
And I take it, what I was catching on is that Doug thought e cubed minus e was e squared.
But what she
They're
did,
not like terms, so
what she did was she did like
Why are
e
they not like
cubed
terms?
over.
they're at the same
I
exponent.
had, oh, okay. I had e cubed over 3 minus e over 3.
You're so mean.
Which would be a 5th grade answer then.
Yeah.
Exactly. I don't think you'd see that one, but it's a 5th right answer.
You never know.
Exactly. Okay, guys, D. We gotta keep moving if we have any chance.
Squared.
Yeah, it should be e to 2x.
No.
Use
it's
the denominator.
Why can't it be e to 2x?
Do one. Wait, why can't it be that?
If we do e to 2x,
No x.
we then have
No x minus.
this 1, we need to
Oh, dang it.
be able to have the derivative of
I'm
something,
not happy.
okay? And if we just do e to the 2x, yeah, okay, derivative of e to the 2x is going to be this 2e to the 2x, but then we've got this 1 here, which,
I thought there were,
It's
but
just
it's
the entire
derivative, so
one
it's 0.
part.
Right? If you do 1 plus e to the 2x, and then you take the derivative, it's a constant, so the constant is
You need
0.
the e in there still.
Yeah, but
You wouldn't get the e if it was just 2x. It was
Hold
just
on a
2x.
No, I'm
Q
saying it'd
is
be
1
1
plus
plus
e to the
e to the 2x.
That's all it
That's
is.
you.
That's you.
I know I got it.
That makes sense.
Okay,
That makes sense,
okay,
right?
okay, so on mine, which is where my brain was at, okay, and where I was first going, is that I used u as the entire denominator,
Yes.
okay, and that is an option. If you use u as the entire denominator, and then it works for our numerator. Now, if you wanted to use u as just e to the 2x, it would be doable. You would just be then integrating 1 over 1 plus u, which is still going to be that same natural log type thing. Okay? So it would be doable. Okay. I'm going to try and go quick because we are not where we need to be. I mean, we're having good discussion, but okay. So u is my denominator. 1 plus e to the 2x. du. Derivative of 1 is 0. Derivative of e to the 2x.
2e to the 2x dx.
E to the 2x times the derivative of 2x, which is 2, times dx.
So what's the-
Do we have matchy-matchy?
Yes.
Okay, 2e to the 2x, it's there.
X equals 0, u equals
So we have these x values. When x equals 0,
u equals
u is 1 plus e to the 2 times 0. And I wrote that out on purpose this time. 2 times 0 is going to be 0. E to the 0 is, anything raised to 0 is 1. So it's going to become 1 plus 1. So u is 2. Are you there?
Yeah.
And then our other one is x equals 3. So 1 plus e to the 6th, and that one's not going anywhere, is it?
Is that just what your u is?
Those are my u's. Yep. Okay. Okay. 1 plus e to the 2x is u. So u in the denominator. 2e to the 2x dx. 2e to the 2x dx is du. My boundaries were 0 to 3. Now they are 2 to 1 plus e to the 6th.
What's larger? Is that right?
Because e itself is like 2.718.
Oh, okay.
So 2.718 raised to the 6 plus 1, definitely bigger. Okay, good enough answer?
Yes.
Okay. Integral of 1 over u,
natural log.
natural log of u, evaluated from 2.
That must be natural log of 1 plus e to the 6 minus natural log of 2.
Can you repeat that?
Wait, you don't put the x's in again?
No, you put the
No, because we did this.
Oh my god. What? I'm sorry. This one up
Because,
here I put in the u's, and that's how I got.
Can I just put that in my calculator?
not on the non-calculator portion, you can't. Now, did I leave it as this? Okay, I did leave it as this. I will say, and I didn't think about this till after I wrote it, 1 plus e to the 6. Is 1 plus e to the 6 positive?
Yes.
Do you have to have absolute value to guarantee that?
No.
No. So could you just make that parentheses?
I did.
Yeah. Will absolute value make it wrong?
No.
No. But they're not necessary is what I'm saying.
Is there any way to solve that other than a calculator?
What, that?
Yeah.
We could write it as 1 natural log if you wanted. Because I just looked, and I have this in my notes, but 2 logs being subtracted is 1 log divided. That would be equivalent too. You know.
But that's last year's.
Yeah.
I agree.
But
So,
last
yeah.
year's stuff might be
Let's
like-
leave that in
Sophie.
last year.
Yes.
If we do this part
I got it.
and change these x values to u's, we don't go back. Now, if I don't change these and I want to still use 0 and 3, then at this point I do go back and plug in whatever
it was
it
just
is. But
different
that,
because there was an x in u
okay.
up here, and I
Okay.
think that's what caught me off guard.
That makes more
I've
sense
got
too.
it now.
Okay. Oh, that's right. Yeah, okay.
Oh, dang it. Okay.
Are you done?
Yeah. You're on video.
Nothing. We can all go back and listen to that later.
You're on video.
You're being recorded.
Okay. E and F. Thoughts on E?
X squared.
Because the derivative of x squared is 2x, which we see the x, right? 2's we don't care about. So, okay. U is x squared. Du is 2x dx. We don't see the 2, so 1/2 du is x dx.
No.
The 5 is the base.
Yeah.
So we're gonna, when we do this, we're gonna be doing 5 to the u. The 5, it's not a constant, it is our base. So we're gonna have to use that rule that none of us remember, and we're all gonna have to go look up.
What rule?
No, it's
I don't think I have my.
it's a to the u over ln.
It's an integration rule, it's in your notes.
Oh.
Okay, now,
Off the dome.
we see that, we see that. Okay. These are x's. If x equals 0, u is
Oh, 0.
0 squared, which is 0. If x equals 1, u is 1 squared 1. Wow, that was an interesting change. Okay,
I think it should just be harder than that.
okay.
Yeah.
So,
Don't speak to someone.
5 to the x squared is going to be 5 to the u. X dx
Raise the U.
is, yeah. Sorry, that was 5 raised to the u if you made my mistake. X dx is 1/2 du. My boundaries of 0 to 1 change to be
0 to 1.
0 and 1. 1/2 is out front. I believe the very first page of these notes
Yeah.
has the integral. Right here, guys. Okay, this is like integrating, the integral of a to u is like integrating 2 to the x. Okay, so a to the u, which is going to be the same thing, like in this case 2 to the x over ln 2. This was our example we talked about yesterday, right?
Yeah.
Ours was 5 to the u. So we're going to have 5 to the u over ln 5.
I didn't finish. It's not
Evaluated from
5 to
second time within the same problem, I've made that same mistake, isn't it? Okay. Are you guys doing better than I am, I hope? Okay. Again, the 1/2 is a constant. I would leave it out front. In all honesty, what is ln 5? It is a constant, yes?
So you do.
So we have options here. What I started to do is say that it's 5 to the first over ln 5 minus 5 to the 0 over ln 5. However, what you could have done is right here, this is a constant, yes? This is a constant. So what I would expect to see, what calculus people would probably do is say that this is 1 over 2 natural log of 5, and then you're just plugging into 5 to the u. Did that make sense? Do you have to do it that way? No. 5 to the first is 5. 5 to the 0 is 1. So 1 over 2 natural log of 5 times 4, which is 4 over 2 natural log of 5, which is
Q over natural. That was great.
if you continued this way and you thought, I didn't like that, you could have. You could have continued this way. We would have had 5 over natural log of 5 minus 1 over natural log of 5. What you need to realize is that these are fractions with a common denominator, aren't they? So you could have just said then 4 over natural log of 5. Okay, which, again, it gets you to the same answer, doesn't it? Do this or this?
Do F.
Oh, F?
Yeah, it's basically the same thing.
You're seeing that one?
Q equals cosine, negative sine x.
I agree.
Negative out.
It's not bad.
Yeah.
You want to try some of the others?
Yes.
Okay.
Because that's completing the square, so.
I do agree, for the record, that you would be cosine x. I will tell you. There's your final answer.
Oh, yeah, that hurt.
Number
Okay.
E was E by square.
So, okay. Example 3. Evaluate by completing the square. Okay.
I forgot how
As this is right now, okay, we don't really have a good way to look at this.
No.
Okay, I mean, there's not like something we can use for use substitution. There's not like, it's just blah, you know? So this is where, as you can see in the directions, they recommend completing the square. Now, the idea of completing the square, if something is in the form that you complete the square, it can be factored into 2 identical parentheses. Okay? Which way do I want to show this? Okay, I'm gonna go one way for a moment down here, but then just hold on for a moment, okay? Don't write anything down yet. And I don't know, maybe you'll want to do it this way after you see it. But if we think, okay, this is what I taught back in pre-calc and probably algebra 2, more pre-calc, I guess. Algebra 2 also, is that when we're completing the square, okay, x squared plus 12x, you leave the blank. We move the 37 outside, right? What's the formula to get this magical number here?
Isn't it B over A squared or something similar? Something squared, right?
B squared over. No.
B over A squared.
B over
C.
A plus C.
2! You guys were getting it. I was giving up, sorry. So, in this case,
What?
and this is completing the square. We did this last year in pre-calc.
Yeah.
Okay. Now,
We paid attention.
first of all, A has to be 1. This has to be 1x squared to the work. So B is 12. 12 divided by 2 squared.
36.
So that means we add 36 here. We don't have another side of the equation to add 36 to. We have to keep this balanced, so that means we subtract 36. Well, 37 minus 36 is, so this is x squared plus 12x plus 36 plus 1. Okay? Now, what I have this written in my notes as is that basically, okay, it's x squared plus 12x. And then if you think about it, what number completes a square? And that was the number of 36, yes? Well, this has to be equivalent. So what am I missing? In other words, you still need a plus 1 here. Okay? So that way you have your x squared plus 12x plus, in other words, I haven't changed anything, have I? I just rewrote it in a different form. Are you seeing what I'm saying there?
Yes.
Okay? Now, Could you also still do it this way? And might you want to? I don't know. But if you can see it this way and just be like, okay, x squared plus 12x, there we go, plus 36. And then I still have the plus 1 there. What do you know about x squared plus 12x plus 36?
That's 6 squared.
So then we have x plus 6 squared plus 1. Now, that's all supposed to be my denominator, isn't it?
Which that brings you what?
Okay. My notes aren't making. And by the way, that formula we used was b over 2 squared. Okay. Now, let me rewrite where we're at. We're integrating dx over x plus 6 squared plus 1. I heard you guys whispering out there.
Is it?
I don't know where you guys ended up, but I heard discussion. I just don't know where you ended up.
Wait. Wouldn't it be like 2 and then the x plus 6 plus 1 is the derivative of.
We're not doing derivatives right now.
Oh.
All I did was take this x squared plus 12x plus 37 and showed that, okay, it's x squared plus 12x plus 36 plus 1, which means I can factor it. Okay? What is this in the form of?
An inverse.
An inverse? Which inverse?
Tangent.
Tangent inverse, because there's no square root.
Oh, I was right.
Okay? So now, if you, okay, because I do better teaching this if I have it in front of me. If you go back to that first page, the integral of du over a squared plus u squared is equal to 1 over a tangent inverse of u over a. Now, so that orange is just the rule.
Is that yesterday?
Yeah.
It's the first page of the notes, so. Okay, that is just the rule.
Cool.
Now, with that in mind, what's going in place, in order to basically write this answer, what are u and a?
A is x, U is 6.
What the?
A is 6, U is x.
No.
Oh, A is
A is x plus 6.
U is 1.
U is 1.
Flip that. Because, okay, only because u represents the variable.
Yeah.
A is a constant.
Oh.
Oh.
Okay.
U is x plus 6.
So
A is 1.
this is the idea of u squared, and this is the idea of a squared. Okay, so realizing u is here on top, u is your variable. A is a constant. So we're using u as x plus 6, a as 1. Just u, not u squared is x plus 6 squared. So just u itself.
Yeah.
Okay? I know, you guys are not loving me right now. Okay, so, huh?
You just don't. Those are like the most people work with this.
I know, we don't work with these inverses a lot, and they're rough anyways. We're ready to write the answer.
Okay.
Your answer is filling this in right here.
Yeah.
So, 1 over a, which is 1.
Tangent inverse.
Tan inverse of
X plus 6.
x plus 6 over 1. Did we really need the ones? No.
Tangent inverse of x.
Plus U.
Oh,
What?
What? Womp womp.
It's indefinite.
You can't do that to me. I don't just.
Welcome to 18
Hate,
count.
hate, hate. Double hate.
I'm sorry, I wasn't really expecting that. It was kind of funny.
B's.
Must admit. Okay, are we good?
Yeah.
Okay.
Fine.
B looks like another inverse.
It is.
Except it's not tangent inverse, is it?
It's
Sine.
yeah.
What is it?
Sine.
Okay. Now, we still have the same situation in that we need a perfect square. Okay? Or we need the similar situation of what we have. So, I'm not going to write the whole thing out right now. We're just going to worry about 4x minus x squared. Well, kind of like over here. I'm going to worry about that, then I'll come back and put it back together.
It'd be 4.
Now, 4x minus x squared. Let's reverse that. If we reverse that, that is,
Negative.
oh, we can't take the square root because there are terms being added and subtracted if that's what you're trying to do. Okay, negative x squared plus 4x. Now, no, but you gave me your quiz and your corrections, right? Yes. Okay. Negative x squared plus 4x. We cannot complete this square in this form because
Negative x squared.
it's a negative x squared. We need that to be a 1x squared. So we're going to take the negative and just factor it out.
X squared minus 4x.
It becomes positive x squared minus 4x, right? I'm going to leave a gap so I can complete the square.
Is it 4 plus 4?
Plus 2 minus 2.
Yeah.
Plus 4.
Negative 4 officially divided by 2 is negative 2. Negative 2 squared is 4. If we add 4 here,
We have to add 4.
This is subtract.
Subtract 4 out.
Wait, no, add 4 because it's
No.
negative.
Yeah, there you go.
You're right, Mario.
okay. Here, wait, let me write this different.
Yeah, I was right.
We're officially, I am going to subtract. I am going to subtract this 4 times this negative 1, which ultimately comes into adding 4. So anytime there's something factored outside. So this 4 that got added right here, yes?
Oh, okay.
It actually is not just a 4, it is a negative 4. So really, if this is a negative 4, I need to be ultimately adding 4. That's the big picture.
Okay.
How I always show it, though, as a teaching tool is, it was adding, we're subtracting, it's a 4, but multiply by what's out there. Okay, so now it's negative. X squared minus 4x plus 4 does what?
Factors.
Into?
X minus 2.
Plus 4.
Now, when we put this back in the radical, which I am ready to do, I'm going to reverse this order. Because when we get to the form, it's that a squared minus u squared, and we want this to be in that same form. So we're going to rewrite this. Dx over the square root, and instead of me putting this negative x minus 2 squared out front, I'm going to start with 4 minus x minus 2 squared. All I've done in all that red is take this original piece and rewrite it. That's all I've done. Okay? Now, we already decided that this looks like a
Sine inverse.
sine inverse. The rule for sine inverse is du over the square root of
A squared minus 2.
a squared minus u squared is equal to, is it 1 over a, I think?
You.
No, it's not. It's just sine inverse of u over a.
A is 4.
Nope.
Is 2.
Square root of 4.
So 2.
Because right here, this is a squared minus u squared. So that means a is 2 and u is
X minus 2.
x minus 2. So
Sine inverse of X minus 2 over 2. Let's see.
Let's see.
There you go.
Okay, now if I recall the last two,
Mario's clutch on this stuff.
okay, that's what I thought. The last two, if you look at the topic, it says change of variables challenge. No, we don't. But if I recall, I was trying to decide if either of them we need to look at, but I'm not. Honestly, I think we're okay without those. I'm trying to think here.
I'm not ready for this.
A is a definite challenge. I don't know, you know. B is more doable than A. A is the challenge that gets ugly, and I don't know that we're up for that today, so. B would be more doable, but. Okay, are we good then? Unless you guys want to see any of that. As always, you guys have
Yeah.
anything that I ever skip or we choose to skip, you guys have access to, right? So always feel free to take advantage of that and look it up and ask questions if you want. Okay, have this